Um, Good afternoon, my YouTube viewers. It's Crystal here. I'm just here because I want to make another video. We're going to do a code review on simple linear regression. And basically, the reason why we're going through simple linear regression is because I'm studying inferential statistics. Now, inferential statistics is a branch of statistics that uses sample data to make predictions or draw conclusions about a larger population. And they use regression analysis in inferential statistics. And so we're going to go through simple linear regression just to give a quick demonstration of regression analysis. And so what I'll do is this is on a Kaggle Jupyter notebook, and so what I will do is when I upload the video, I will give you the link to the Jupyter notebook so you can study along with me if you want. But so the data set that we're going to use is salary data, simple linear regression. So after we have created our Jupyter notebook, what we want to do is we want to import the libraries that we're going to need to execute the program. So we're going to import pandas to create the data frame and process the data. We're going to import NumPy to create NumPy arrays and make numerical computations. We're going to import OS to go into the operating system and retrieve the data set. We're going to import matplotlib.pyplot SPLT to visualize the data, and we're going to import Seaborn to statistically visualize the data. We're also going to import sklearn, which is going to give us our machine learning functionality. So after we have imported the libraries, what we're going to need to do is use the OS library to go into the operating system and retrieve the file. The file is salarydata.csv. Then what we're going to do is we're going to use pandas to read the file, and we're going to call it the data frame df. And so this is the salaries, and it gives you 30 salaries. So it'll give you the years of experience and the salary. And one thing I can tell you here is I have lots of experience. I have definitely close to 50 years of experience, and I don't earn anywhere close to 121,872. So I guess my experience isn't considered that valuable. And then what we're going to do is we're going to analyze the data frame. And so we're going to use the describe function to analyze the count, which is 30, the mean, the standard deviation, the minimum, 25%, 50%, 75%, and maximum. And that's a type of statistics as well, but it's not inferential statistics. I think it's another type of statistics, but it's not inferential statistics. So now what we're going to do is we're going to use Seaborn to make a diagram of the distribution of the salary. So you can see that the 60,000 gets the most hits, whereas the other ones, they get less. We're also going to create a scatter plot to find out how the years of experience relate to the salary. So you can see the more years of experience that you have, the higher the salary. But that's not true in my case. My case is an exception. And then we're going to define the dependent and the independent variables. Your X is going to be your the first column, and your y is going to be the second column. Then what we're going to do is we're going to use sklearn to split the data set up into training and testing sets. So you can see we've got our training and our testing set. So, and then what we're going to do, but before we do that, I just wanted to check something because this is the independent variable and this is the independent variable. So I'm going to assume that the independent variable is the years of experience and the dependent variable is the salary. So now we're going to go back to defining the model. We're going to use sklearn's linear regression. So regressor equals linear regression dot fit x train y train, and then we're going to check the score. So you have 96% accuracy. And then what we're going to do is we're going to make predictions on the test set. And I had some problems getting it to work when I was working on it. So I just got the dimension because it has to be one dimension when I made my data frame. So now what we're going to do is, and we had to create a NumPy array for Y test and convert it into a NumPy array and make it only one dimensional, which is what I did. And then so what we're going to do is we're going to make predictions on the test set and the train set. And then we're going to have to convert the YPRED test into a NumPy array and reshape it to make it one dimensional as well, because it has to be one dimensional to go into the dictionary that we use to make the data frame. So it worked. It took me a while to get it to work, but it worked. So that's the code to just make the little data frame, because I wanted to make the data frame just so you can see the actual values opposed to the predicted values. So now we're going to visualize the predictions. We visualize the training set. So this is your training set that's the data's been trained. And now we're going to visualize our test set. And this is our test set that's been trained as well. So now what we're going to do is we're going to print off the coefficient and the intercept. So the coefficient is a measure of how much the dependent variable y changes for a unit change in the independent variable x. And your intercept is the value of the response variable when all the predictor variables are equal to 0. So that's your coefficient and your intercept that you use in linear regression. We're going to calculate error, which is going to be the RMSE. Now, what happened is sklearn, when you go into the sklearn website, they've got a whole new website that's completely different from what they had previously. And so used to, you could calculate the mean squared error, and in the mean squared error, there would be a hyperparameter that you could turn on to get the RMSE, that's your root mean squared error. But whenever I went into it this time, I didn't see that hyperparameter. So what I did was I made RMSE, which is the square root of mean squared error, because that's it, root mean squared error. But I have since gone in and looked at sklearn, and I found out now sklearn actually has a root mean squared error function that you can use, but I didn't know you could use that function when I did this program. So you can use mean squared error and square root it to make a root mean squared error, or you can use sklearn's RMSE, which I will be using in the future, but I didn't know they had it. They've just completely revamped their website, and it's got all these new bells and whistles, and it's going to take me a while to get used to it. Personally, I like their old website better, but hey ho, we have to move with the times, don't we? So that's it. That's your RMSC is 7059.04362. So that's your error of your linear regression model. And so that also completes this video. I hope you found the video interesting and it helps you in your studies. And linear regression is used in inferential statistics, which is why I made this program and made this video. So thank you so much for watching my video. If you like my video, please like and subscribe. I look forward to seeing you in the next video.